All right, let's get started. Good morning, everybody. My name is Daniel Masset, and I'll be giving today's webinar. We're going to be looking at spatial data analysis using the R language for statistical computing. So this is meant for beginners, people who are getting started with spatial data analysis. And so we're going to introduce some basic concepts when it comes to analyzing spatial data. So a few housekeeping issues. If the webinar is not loading, you might probably want to refresh your web browser. You could try doing that, or you could try logging out and then logging back in, and hope that helps. And also, let's hold questions until the end of the webinar, and so we could get into those at the end. I think we'll have enough time to do that at the end. So I would like, first of all, to thank Domino Data Lab for hosting this webinar. And so if you've never heard of Domino, they are a data science and engineering company based in California. And so what they do is they provide a platform called Domino that lets you run analysis using different programming languages, and they lets you run large data, and you're able to share, collaborate with other data scientists within your group, and you're able to deploy your analytics as APIs. And so I want to thank Domino Data Lab for hosting this webinar. So this is what we're going to look at today. This is briefly what we're going to look at. Why would we use R for spatial data analysis? We want to try to answer that question because some of you might be answering and trying to compare with different other tools. And then to help us, get started with spatial data analysis, we'll go through a typical data analysis lifecycle where we shall get some data, do some preparation, exploration, and then some visualization. You'll see some of the cool packages that let you do that within the R environment. All right. So let's try to answer this question first. So you might be seated wondering, why would I use a statistical programming language like R to do spatial data analysis? And some of these are the reasons that I like using R. So first of all, it's free and it's open source. So you don't have to spend anything at all, actually. You can just download it off the CRAN website, the R-Proj website. And then secondly, reproducibility. This one is good for, especially if you're doing research work at a university or in a lab, or you're collaborating with a lot of people in your data science team, or even for your future self. You want to be able to reproduce your analysis, and other people in the field, especially in the medical field, if you claim you've discovered something new, they want to verify your claims. And so they can really use functionalities in our programming language to reproduce your analysis. And then probably one of the third reasons here, which I guess is one of the strongest reasons why a lot of people use R, is because of the numerous extensions in form of R packages that provide a lot of other functionalities that you would need. So there are a lot of packages to date. I think there are more than 8,000 packages for analysis data in R. So you can do data managing, geostatistics, statistical modeling. Yeah, literally anything that you can think of. There's somebody out there who's probably written a package and they've put it up on CRAN or on GitHub or somewhere else. And so you can just download it and use it. And also The other neat feature about the R community is that there are over 2 million users worldwide that use the R programming language. And so you're able to collaborate with a lot of people online, ask questions on Stack Overflow and on other mailing lists or on Google Groups. And so before I wanted us to see some of the neat things that the R language can do. Like, for example, this is a thematic map. For a lot of you that use other proprietary software like Azure GIS or QGIS, this is a non-trivial issue. So this was produced using the R programming language, and we'll see how to do this. Another one are choropleth maps. This can also be done in R. And if you want to do some density maps as well, there are extension packages that you can use to do this. And so I just wanted to show you, just before we get our hands dirty and wet with spatial analysis, that this is actually possible. So before we get into the demo, I just wanted to introduce the history of spatial data analysis in R. So before 2003, there were numerous packages for spatial data analysis, and they all had their own assumptions. They made their own assumptions about spatial data, and so it was difficult to move spatial objects written from one package to another. And so this made it very difficult before then. But then in 2003, a group of OWL developers came together and they wanted to write a package that extends classes and methods, that base classes and methods for spatial data analysis. And so they wrote this SP package. And if you're a new user and you want to use R for spatial data analysis, I'll highly recommend that you use this SP package first, because it provides a unified structure for analyzing spatial data. And so provides a single set of classes and methods. And with this, you could now be able to move spatial objects from one package to another without breaking your code. And so if you're a new user, you probably want to get into this SP package and look more into its functionality. And so having a single set of classes is a very neat feature, because you can move spatial objects and data from different packages. So you can do visualization in one, you can be using the same spatial object, and then you can do data managing using another package. You can do geostatistics and any other spatial data task that you may think of using the same objects without having your code break. And so the package as well extends base functions in the R programming language so that they can work on spatial objects. And then it provides the sort plotting methods. So having a single set of classes has made it really very easy. And since then, there's been an exponential increase of packages being written for spatial data analysis. And so we'll look at some of them. So usually when I start working, there are some go-to packages for that I like to load into my R environment, including the following. So obviously, I would start with the SP package, and I would highly encourage you, if you're just starting out, use the SP package first and create your spatial objects. And then there's the R GDAL package. If you want to import different spatial data formats into your R environment. So that includes shape files, points, lines, grids. The R GDAL package provides such functionality. Then there's the R Geos package, the raster package. And then when it comes to visualization, there are plenty of packages in the R community, including TMAP for creating thematic maps, ggplot2 for users who are very common users of the R programming language are probably familiar with ggplot2, written by Dr. Hadley Wickham, provides very good functionality for producing very beautiful graphics within the R programming language. And so, yes, you can still use ggplot2 for spatial data, as we shall see. ggmap provides base maps like Google Maps. You want to import base maps of Google Maps, OpenStreetMaps, and other base maps into your environment, onto your maps, you can use ggmap. And then if you're looking for interactivity within your maps, there's a package called Leaflet, written by the folks at our studio. So you can bring that in and you can have interactive maps that you can deploy within your website or your Shiny applications. And then there are several other packages. So if I put here a link down here, you could go to the cron task view, and there is a link right here. You can actually go to this cron task view, and you can find a lot of other packages for spatial data analysis. So you have packages for creating classes, for handling spatial data, reading and writing spatial data, and much more. And so there's a lot more in there, but I would encourage you to first start with the SP package, because that forms the basis for the rest of work that you might do. So let's get into, enough with the slides. Let's get into a demo. And we'll start first with preparing our data. And in this demo, we'll use crime data from the Houston Police Department. This was collected over a period from January 2010 to August 10. So let's head over to our studio. And so this is my working environment. And for those of you who are new to R or new to our studio, this is an integrated development environment that you can use to organize your R projects, your code, your data. And so here I'm gonna go through some code here. So let's start by loading in some of our favorite packages. Mine include the following, so I'll just run this. And so let's load in some packages here, some libraries here, including the ones that we saw on the slides. So that is in there. And also, if you're wondering, you're probably seeing there's a lot of text and then there's code combined all together within the same script. So there is this writing platform called R Markdown that lets you combine text and code within the same environment. And so you can export this, you can create PDFs or HTML files or even Word documents using this writing platform called R Markdown, and using the knitr function that comes along with our studio here. So I can combine text and I can also have code in here. All right, so let's read in our data. So like I said, we'll use crime data from the Houston Police Department. And it's also, that data is also available in the ggmap package. All you just have to do is say data and then crime, and you'll get that data. So let me just run this using the base R function for reading in data. So I'm going to create a data frame, an object here called crime.df, which is a data frame that reads in crime data. And it's a CSV file. It's relatively small, I believe, just 86 observations. So read that in. let's look at the structure here. After reading the data, you may probably want to look at the structure of your data frame. So let's do that. And so if I scroll up here, I'll see that we have approximately 86,000 observations and 17 variables as well. So here in another pane down here in the environment, you can see the data object here. And so a nice feature about RStudio is you could easily just click here and be able to open up a data view window, and you can be able to explore your data here. So let me just pop this out in a new window. So we could have a bigger window here. And quickly, after you've read in your data, you're probably curious, you want to see what your data is made of. And so we can see here, we have time, date, hour, and other variables in our data here. So like if I scroll all the way to the right, we have longitude and latitude features here. And so we'll use these two variables here to geocode our data. So let me go ahead and close that and then head back to the file here. All right, so that is our crime data. And then there's some other neat functions within R to look at your data. Like for example, here you could look at the first 5 observations, but we're obviously going through that. So head does that. And then if you want to get some summary statistics, you could use this summary function. And so it gives you descriptive statistics like the minimum, the first quartile, the median, and things like that. And so here we can already see we have some 5 observations with latitude and longitude records being NAs. And so we would need to deal with that. So these are neat functions that help you, quickly glimpse over your data and get a sense of what your data looks like. But we're still working in a local R data frame. So we'll probably want to filter out these NAs, and then the date, won't use it here, but for the sake of just doing this, let's format the date into a date format. And so that does that. And so we've read in the data. It's a local R data frame. But the problem with working with local R data frames is that, most of the spatial packages will not understand what it is. Your code will break when you try to run your spatial analysis on a local R data frame. And so we'll use functionalities and methods within the SP package to convert our local data frame into a spatial data frame. And so that's why at the beginning I talked about the SP package providing us with a single set of classes that we can use between different spatial packages. And so let's use this spatial points method here and then create a coordinates object using the long and the lat variables within our crime data frame. So I'll go ahead and run that. Let me just go ahead and run all these 3 lines, and then I'll explain what they mean. So here we've created a coordinates object here, and we've used spatial points to tell R that those 2 columns, those 2 variables, long and lat, are actually our coordinates. And so now R recognizes them. Unlike in the previous local data frame, it just identified them as numbers and they didn't mean anything to R. Now R knows that they are longitude and latitude variables. So, and then the next line here is, now we create a spatial points data frame combining our coordinates and the crime data. And then we use the proj for string method here to specify the coordinate reference system of this data. And so since I'm familiar with the data, I've looked at it, I know that it is in a geographic coordinate system. And so WGS84, for those who have played with a lot of spatial data in GIS, you probably know, you've heard of WGS84 as a type of coordinate reference system. And so now we have our crime spatial data frame. And so if you want to see other classes of type spatial, you can just say get class spatial, and you'll be able to see them here. So we have spatial points, spatial multi-points, spatial grid, and spatial polygons, and much more. And so depending on what data type that you have, it could be lines, it could be points, polygons, grids. You could convert them into a spatial object. And so a lot of spatial packages will be able to play nice with those objects. And so if we quickly look at the structure of our new spatial object, we can see that now it is of the form spatial points data frame. So this is very important. We've converted our data from a local R data frame into a spatial points data frame. And so if you're new and getting into this for the very first time, you'd want to do this, prepare your data into this format before you can start doing other complex analysis. So okay, let's get back to the slides. And so when you're looking at the structure of a spatial points data frame, it has 5 slots, including the data. So all your data is read into the data slot, and you could think of slots as components within your spatial points data frame. And then, so this one has 5 slots here. The codes, NRS, those are the column positions where in the data your coordinates were taken from. So if you're looking for coordinates within your spatial points data frame, they're within the codes slot. And then you have the B box, that is the bounding box of the coordinate. And then the proj for string gives you your coordinate reference system. So I just wanted to stress this out. This is very important. You cannot stress this enough when you're working with spatial data types. The different types of coordinate reference systems that are out there. Suppose you have 2 files that you want to bring into R, or even a proprietary GIS system like SUGIS or QGIS. And if your objects have 2 different coordinate systems, you may have problems overlapping. If they're within the same area, you may have problems. You may find one is in the right location and then the other is in the middle of the ocean somewhere. And so that happens a lot to new beginners. And so you have to understand the coordinate reference systems of your data. So there are 2 types of coordinate reference system. You have the geographic coordinate system, and that is given in longitude and latitude. And so an example is the WGS84, and this represents the Earth as a sphere. And then the other type is the Cartesian, projected or planar coordinate system, your XYZs. And typically these will have SI units of distance like meters of length, like meters or kilometers or feet. And this type of coordinate reference system represents the Earth as a flat surface. And so it's projecting the spherical surface, the ellipsoid, into a planar system. But under the projected coordinate system, you still have several types, but the main ones here that I'll list are the state plane, NADS 83. So that one's mostly used here in the United States. For example, Nevada would use, some regions in Nevada would use Nevada state plane, NADS 83 East or West. And another one, common one, is the UTM, the Universal Transverse Mercator. And for example, Nevada uses UTM Zone 11, and then 11 North, and then some of the areas like South Africa would use UTM Zone 34S and 35S. And so before you start, geocoding your data, it's really very important to know the coordinate systems. So other than points, we can play around with other spatial data types like polygons. And so we could bring in shapefiles, for example, shapefile polygons, and you could download those from different sources. If you're in the US, you'd probably want to go to the US Census website. And then for other individuals that are curious about sources of spatial data, if you're not in the US, there's this website here that I stumbled upon. It's called Diva GIS. You can be able to download spatial objects, spatial types, shapefiles for every country. Here, you can just search for your country, and then you can get for roadways, population, administrative areas. And so I usually go to this website to get shapefiles for other regions that I'm interested in. So that is a very nice resource. All right, so we've brought in our data, we've converted it into a spatial object. Now we want to look more into it. What is it made of? And so there are some foundation methods in R that you're probably familiar with, like the plot, summary, and print methods that have been extended now, that were extended then to work on spatial objects. So you can do a plot, a summary, and a print on your spatial object. But there are other methods that are provided by the SP package that you can use. For example, the bbox, the proj for string. And you probably noticed when you're extracting data or variables from a spatial object, you would need to use the @ symbol instead of the usual $ symbol that we'd use in R. So you want to look out for that. So let's head into and look at some code here for exploring. I'll just scroll down here. All right. So you've brought in your data, you've created a spatial object, and now you want to save it. So you can save it out just to maintain the spatial quality so that you can be able to bring it in later and also maintain the spatial integrity. And so let's scroll down here. So the RGDAL package also provides another neat function for reading and writing out spatial objects. So for example, we have a crime spatial data frame here in R, but I want to save it as a shapefile. So maybe I could use it in GIS, in Esri GIS or QGIS. So the write OGR does that, and then you can specify the driver as Esri shapefile. And so that saves it in there. And so you can go ahead and use it within your proprietary GIS system. So another way that you could, so you could also read in, you've downloaded maybe your shapefiles from a website somewhere, and so you want to read it into R, you can still do that using the read OGR function. And so here I'll just bring in this data. It's a zip file. Let me just do that. And then read it in. So if I do class, you'll see that it is a spatial polygons data frame. Now we have a polygons data frame. So now we have two spatial objects, a spatial polygons data frame and a spatial points data frame. And so we can be able to work with them together. And so, yeah, so we can also bring in, we can also use the read shape spatial from the Maples package for reading in data. So there are different ways that you can read in spatial objects. And so just to make sure that we have the right file, you could quickly use the plot method here to try to bring it up. Hope this, yeah, so it's still running there. We'll wait for it to run, we'll let it run, but we'll continue going forward here. Let me just expand my window here. And so, yeah, just to verify quickly that, we brought in the right shape files. So you can do that neatly with the plot method. So like I mentioned earlier, there are richer methods provided by the SP package. For example, bbox here gives us the bounding area of our spatial object. And so we can see the minimum and max of our latitude here. So you want to know the extents of your spatial objects, you could use that. And also, if you've brought in some data and you still haven't evaluated it, looked at it, you could look at the coordinate reference system just to make sure you have the right coordinate reference system there. And then so I'd mentioned that, to extract data from a spatial object, you need to use the @ symbol here. Like for example, let's run that. And so you can bring in data, reading the data. So we can also, this one reads in the coordinates here, the first 4. And so you could use the @ symbol to do that. And then there's some other methods for spatial data analysis. You could use the subset if you're just interested in observations within a certain region. You could use the subset. So here we're trying to get downtown crimes only. So that does it. And so you have an object here that has crime data. And so for your downtown. So when it comes to visualization, let's head back here into our slides. R provides the plot method as a traditional plot system for creating your visualizations. And so it has been extended to work on spatial objects. And so to create your visualizations, you just need to use it and then add layers on top of it using the argument add is equals to true. But then you'd want to use external libraries because they have more functionality. You can produce a lot of beautiful maps and you can do much more. And so some of my go-to packages are ggplot2, plotly, ggmap, tmap, and leaflet. But there are a lot more packages that you can look into. And so these can be used to create visualizations. And so we've prepared our data. It's all ready. We're ready to go through it. So what we can do is produce some good visualizations here. So let me just run this really quickly here. This one just plots. And then when you want to add layers on top of it, you could just say add is equals to true using that argument. So here we have Texas, the map of Texas with the lat and the long. And so we want to add data onto it. So just use the add is equals to true. So you can, I don't know whether that is legible. Let me try to zoom in and see here. So hope that comes up really quick. Yep. So there we go. And so you could bring in your points and polygons within the same object there within your map. So let's see what else we may want to add. We may want to add a title and the legend. And so we can do that using the add is equals to true command. Hope that runs fast. Okay, there we go. Oh, it looks like it's still, well, all right. So there we go. So I've brought in my title, my legend. And so traditional plotting system provides that functionality. You could use plot, and then the add is equals to true to add layers and other layers. So you could add some other layers on top of this. So we don't want to get into the details here. This is just to introduce packages for spatial data analysis. And so at the end of the slides, I provided a reference so you can look into them in detail. So these are traditional plotting systems. What about external libraries? I mean, we could use popular packages like ggplot2 for doing this. And so let's do that. But here, ggplot2 works on data frames. And so what we could do, we could convert our spatial points data frame into a local data frame that ggplot2 can recognize. And so let's go ahead and do that here using that. And then let me try to run this and hope my computer is fast enough. So let's hope it runs quick enough. So let's do that. Plot that object using ggplot2. And well, it's taken some time to run, but yeah, so ggplot2 provides functionality. You can do that on spatial objects as well, not just only charts and bar graphs. You can do that on spatial data. So the other package is ggmap. So here we go. Looks like my computer is quite slow. Yep. We can be able to see exactly the same thing using ggplot2. Yep, so there we go. So that's one package you'd want to look into. The other package that you want to look into is ggmap. And so the basis of this is that it provides a base map onto which you can plot your spatial objects. And so here we'll use OpenStreetMaps. So this is what it would look like down here. And then you'd want to place layers, plot layers on top of this base map here. So let's maybe bring in our shapefile. There it goes. Bring in our shapefile on top of it. And then we could bring in our crime data as well on top of it. So let me go ahead and run this. And so the basis of the ggmap package is you have your base map, you bring in Google Maps or OpenStreetMaps, and then you can use ggplot2 functionality to create geometries, statistics, or several other objects, layers on top of it. And so it looks like it's still running there. So another package, now we'll leave it running, and then once the map is created, we'll be able to see it. So another package is the leaflet package that provides interactivity. And so you'll have this code later that you can run on your own and see. I'm afraid we're running out of time there. So I'll probably not run the leaflet functionality here. So here we go. Finally, it ran. So this is using the ggmap package. You bring in a base map and then be able to plot your shapefiles and then points on top of it. And so you can export this out as an image or PDF and be able to embed it in your reports. If you're working separately or if you're working R Markdown, it'll just be embedded automatically for you. And so there's a lot more code here that you can run through, but I also wanted to introduce the T-map. This is probably a newer package created just recently, and I like it because it's able to combine maps plus themes and create what they call thematic maps. So this is a good example here. We saw it in our first slide. So you can be able to create such beautiful and rich maps that you can share with your colleagues. And so that was just a little bit introduction into some of the packages that you can use for visualization and also preparation. So the basis of the objective of the webinar was just to give you these basics of spatial data analysis using the R programming language. And so one of the things that you might want to take away from this is being able to create spatial objects that can then be manipulated using different packages within R. And so once you've created your spatial object and you've saved it, you'd want to do more like point pattern analysis or geostatistical analysis. And so your code won't break. So you'll be able to run that. So hopefully sometime in the near future, we'll probably go through another webinar on point pattern analysis so you could see the other packages like the Spatial that you can use for this. And so if you want to read more, I would encourage you to go through actually this first reference here, Applied Spatial Data Analysis with R. It's a book by Roger Beaver and his colleagues. It's under the user reference, use R series, excuse me. And so I provided a link that you can go and get that book and read through it. And so there are some other references here that you can go through so you can get more. And so I wanted to head into the Q&A. Let's get a few questions answered. And so I'll just head into the sidebar here and look for a couple of interesting questions here. Yeah, so there's a question here. Could you create static maps? Yeah, so the ggmap package lets you create those static maps on the background. So you can bring in OpenStreetMaps, Google Maps, and then you can be able to plot your spatial objects on top of it. And then, then I forgot to mention, somebody was asking here, will they be able to download the code and the presentation? Yes, we'll send out a link with the code, the data, and the R scripts as well, so you can be able to run this on your own later on. So let me go through here and look for more questions. So somebody's asking, what are the best packages? So for spatial data analysis, so it really depends on your preferences. So first, before you do anything else, I would encourage that you use the SP package to create spatial objects, and then once you have those spatial objects, you can look into different packages for visualization, for data managing. All right, so let me look for a couple of more questions here. Somebody talked about T-map. Yep. Okay. So a lot of the questions here that have been asked, I've already talked about them in the presentation. Let me go down here to the poll questions. So it's the same questions. Will you get access to the code? Yes. Spatial temporal data. So somebody needs to visualize the path of moving objects. So I'd encourage you to look into the point pattern analysis package, especially Spatial and Stats. You could use those. So SP assumes, so there's a question, does SP assume you're working on 3D objects? So these are mostly 2D objects that you're working on, X and Y's. Somebody's asking here, using the subset function. Yep, you could use the subset function. It's a neat way of subsetting data. Otherwise, you'd want to use the field, you'd want to use dplyr to manipulate your local R data frame and then convert it into a spatial object. Because dplyr works on local R data frames or dplyr data frames. So you could also follow along if you want the text and the code. There is a blog post that we published sometime last month, and it's pretty much about the same. So you could follow along and be able to recreate the same analysis that we've gone through here. Yep, so somebody's asking, can we combine machine learning and spatial data analysis so we can predict earthquakes? Oh yeah, definitely you could do that. There are a lot of packages within the R programming language for machine learning. And so you can bring in, but I believe a lot of them work on local R data frames. So you need to convert your spatial data object into a local R data frame to do that. All right, that's one question there. So somebody's asking, what package would you recommend for cragging analysis? I would recommend looking into Spatial package. You'll be able, if you go to the current task view, you'll be able to see it listed in there, and you can go through it. I believe also Spatial, the package called Spatial, provides such functionality. And so somebody was providing here, there's another question about using a different way of creating coordinates using the using long and lat. Yep, you could do that, but I wanted to show step-by-step for, especially for new users who are just starting out. So you could do it using the coordinates method for specifying your spatial objects. So how are we doing on time? So I think I'd want to end here. So somebody was asking they couldn't see it. So earlier I'd mentioned that you would need to refresh your web browsers so that you could see it. But in any case, the presentation, the slides, the data, the R scripts, R Markdown scripts will be sent out in a link to you so you can access them. They'll be available on the Domino platform and also on GitHub, so you can be able to access them.